Good morning, children. We do the last problem of exercise 5.1. The most skillful problem, challenging you to recall all that you have studied in binomial theorem. Are you thorough with the expansion? Are you familiar with combination formula? In this single problem, we are using the properties of combination, the binomial expansion. Prove that C0 square plus C1 square plus C2 square and so on up to Cn square equals 2n factorial by n factorial the whole square. As I see the LHS, which is C0, C1, C2, let me remember NC0 I will call C0, NC1 I will call C1, NC2 C2 and so on. NCN we call Cn. In the introductory part of binomial as well as combination, we learnt the combination coefficients can also be denoted as C0, C1, C2 and so on up to Cn. This claims us to consider 1 plus x the whole power n. Consider 1 plus x the whole power n. How am I to write it? NC0 1 power n minus 0 x power 0. NC1 1 power n minus 1 x power 1 and so on. The last term NCN 1 power n minus n x power n. The previous term NCN minus 1 1 power n minus n minus 1 into x power n minus 1. X powers keeping on increasing 0, 1, 2 up to n, previous number n minus 1. First term 1 power keeps on decreasing. 1 power any number is 1. So I can rewrite the same expansion as 1 plus x the whole power n is. Instead of NC0, I will write C0. 1 power anything 1, ignore. X power 0 plus NC1, I will write C1. 1 power ignore. X power 1 and so on. The last two terms NCN minus 1 is Cn minus 1. X power n minus 1 plus Cn x power n. Call this as number 1. Now, we know NCR equals NCN minus R. NCR equals NCN minus R. If I apply it here, what about NC0? It will become NCN. What about NC1? It will become NCN minus 1, NCN minus 2 and so on. NCN minus n. So, wherever C0 is coming, I can write Cn. Remember in Pascal's triangle, from the beginning, from the ending, the terms are same. So terms equidistant are same. The main idea is NCR equals NCN minus R. So applying this idea, instead of NC0, I can write NCN. In the similar manner, C0 can be written Cn. So the next step, instead of C0, I can write Cn. Instead of C1, I can write Cn minus 1 and so on. Instead of Cn minus 1, I can write C1, that is n minus 1, which will become C1 x power n minus 1 plus Cn will become C naught x power n. Call this as number 2. So what have we done? Wherever 0, 1, 2, 3 are coming, we replace n minus that number. So 0 will become n minus 0, 1 will become n minus 1, n minus 1 will become n minus 1, and n will become n minus n. As I simplify and I reverse and write it. Write this term first, this term second, like that. So what I get? C naught x power n plus C1 x power n minus 1 and so on. Cn minus 1 x power 1 plus Cn x power 0. So I have just reversed the terms. This term I have written first, this term I have written second. So this term will come as the last. This is also 1 plus x the whole power n only. Now let us multiply 1 and 3. As I multiply, this term into this term will come. So 1 plus x the whole power n into 1 plus x the whole power n. First equation, C naught x power naught plus C1 x power 1 and so on. Cn minus 1 x power n minus 1 plus Cn x power n. The third equation, C naught x power n, C1 x power n minus 1 and so on. Cn minus 1 x power 1 plus Cn x power naught. As I multiply, let me find out C naught square, because that is my expectation in the LHS. When will I get C naught square? Just check. These two I multiply, it becomes C naught square. These two I multiply C1 square. These two I multiply Cn minus 1 square. These two I multiply Cn square. If I want to multiply these terms, what are these terms actually? X power 0 into x power n, that is x power n. X power 1 into x power n minus 1, that is again x power n. Here also x power n, here also x power n. So what am I checking? Coefficient of x power n in this product. I will just multiply like this. C naught into C naught square. C1 into C1 square and so on. Cn minus 1 into Cn minus 1 Cn minus 1 square. Cn into Cn square. And call this as number 4. We have achieved the left hand side of the problem. Now, the same problem, 1 plus x whole power n into 1 plus x whole power n can be written as 1 plus x the whole power 2n as I add the powers. How will I write coefficient of x power n in this problem? It is the same. Now, I need not write the expansion. I can write the general term. If I compare 1 plus x whole power 2n with x plus a the whole power n. X is 1, a is x, n is 2n. We know the general term TR plus 1. What is the general term? NCR, x power n minus r, a power r. What is a? X. I will get x power r. But I want x power n. So put r equals n. As I write Tn plus 1 from here, NCR, that is 2NCR. Instead of r, I will write n. First term power n minus r. 1 power 2n minus n. Second term x power n. So we write from here 2ncn. First term power 2n minus n. Second term power n. As we know, what is NCR formula? NCR formula, n factorial by n minus r factorial into r factorial. Applying the formula, it is 2n factorial by 2n minus n factorial into n factorial. 1 power anything is 1, ignore, into x power n. But I want only coefficient. So what is coefficient of x power n? Coefficient of x power n is 2n factorial by n factorial into n factorial, or 2n factorial by n factorial the whole square. Call it as number 5. Fourth equation gives us the LHS of the required question, and fifth equation gives us the RHS of the required question. As I compare 4 and 5, so comparing 4 and 5, we get the result C0 square, C1 square, etc. Cn square equals to 2n factorial by n factorial the whole square, and hence the problem. Just see what all we use in this problem. The very first idea, as I see the question, C0 square, C1 square, C2 square. Let me remember, C0 to Cn represent NC0, NC1 up to NCn. So naturally, it is a problem in binomial expansion, because now that we are in exercise 5.1, we know it is binomial theorem, binomial expansion. But in the question paper, when you just see the question, you must be able to identify from which section it has come. So, as I see C0 to Cn, let me remember the expansion 1 plus x the whole power n, in which 1 power is ignorable, because 1 power is giving you only 1. Forget it. I am left with x power 0, x power 1 up to x power n. And the coefficients NC0, NC1, we can write C0, C1 up to Cn. The question suggests I want C0 square. So I need to multiply. Before multiplying, let us remember the formula. NCR is NC n minus r. So C0 will become Cn, C1 will become Cn minus 1, and so on. Cn will become C0. So the same problem, by using the combination property, we replace C0 as Cn, C1 as Cn minus 1, and so on, Cn as C0. To get C0 square, let me reverse the last term in the first, the second first from here, and the first will go as the last. We just reverse the terms. From back to front we have reversed. Call this as number 3. Now, because I want squares, I need to multiply the expansions. As I multiply, I don't want all the multiplication terms. I want only C0 square. How do I get it? Multiplying the 2. I want C1 square. Multiplying the 2. I want C2 square. So next terms we want to multiply. How am I to do that? Look at x powers. Here the power 0, here the power n. So it is, when I multiply x power n, here also x power n, here also plus 1 minus 1 cancels, giving us x power n. Here also x power n. So we are checking only the coefficient of x power n. As I check the coefficient of x power n, I get the squares as in the LHS of the problem. Is that all? I need to show the RHS where 2n is coming. So, the same product I can also simplify as 1 plus x whole power n plus n will give us 2n. Now let us write what is coefficient of x power n in this single expansion, for which let us remember the general term. As I remember the general term, it is NCR x power n minus r a power r in x plus a the whole power n, where x is the first term, 1, a is the second term, x, n is the power, that is 2n. But my question is x power n. If I substitute, I will get a power r, that is x power r will come. But I want x power n. So in the place of r, let us put n. So I will get t r plus 1 becoming t n plus 1. NCR 2ncn x power n minus r 1 power 2n minus n a power r, that is x power n. 1 power any number ignore. 2ncn we apply combination formula. What is combination formula? It is NCR equals n factorial by n minus r factorial into r factorial. Here 2n factorial by 2n minus n factorial into n factorial x power n. But I need only coefficient of x power n. So consider only this term, that is 2n factorial by n factorial into n factorial, which is the RHS of the question. So a little before we did LHS, and now that we have arrived at the RHS, compare 4 and 5 so that we attain the expected result of the problem. Why do we say the problem is the most skillful problem? Right from the beginning, check. We are using NC0, NC1, NC2 up to NCn as C0, C1, C2 up to Cn. Combination coefficients. Second formula, NCR is NCn minus r. Wherever C0 is coming, it is Cn minus 0, that is Cn. C1 is Cn minus 1 and so on. Cn is C0. The third formula, we should know to write the expansion in a binomial expansion. Fourth formula, we should know to write the general term in a binomial expansion. Fifth formula, we should know to write the combination formula, NCR. So remembering this many formula and recalling at the right step, and matching the comparison needs a lot of mastery in the subject. Learn well and practice well.